Hi, Rajalakshmi, working as an assistant professor in the Department of ECE at R.M.K College of Engineering and Technology. In the previous videos, we have seen requirement and specification analysis. So after the requirement and specification phase in the embedded system design process, we have is architecture design. So in this video, we are going to consider how to turn a specification into an architecture design. To understand the overall structure of a complex system, we have a methodology which is named as CRC CORD methodology. The CRC CORD methodology is a well-known and useful way to analyze a system structure. It is particularly well suited to object-oriented design because it encourages the encapsulation of data and functions. The acronym CRC stands for the class, responsibility, and collaborators. Classes define the logical groupings of data and functionality. A class may represent a real-world object or it may describe an object that has been created solely to help architect the design. A class has both an internal state and a functional interface. The functional interface describes the class capabilities. Responsibilities describe what the classes do. The responsibility is an informal way of describing that functional interface. The responsibilities provide the class's interface, not its internal implementation. Collaborators are the other classes with which a given class works. The collaborators of a class are simply the classes that it talks to, that is, classes that use its capabilities or it calls upon to help it to do its work. The name CRC card comes from the fact that the methodology is practiced by having people write on index cards. An example card is shown in figure. It has space to write down the class name, its responsibilities and collaborators and other information. The essence of the CRC card methodology is to have people write on these cards, talk about them, and update the cards until they are satisfied with the results. This technique may seem like a primitive way to design computer systems. The CRC methodology is an informal technique and is valuable to tool-based design and coding. Software engineering tools are available that automate the creation of CRC cards. The CRC cards had several important advantages. First, it is easy for non-computer people to create CRC cards. Getting the advice of domain experts, it is very important in system design. The CRC card methodology is informal enough that it will not intimidate non-computer specialists and will allow you to capture their input. Second, it encourages computer specialists to work in group and analyze scenarios. The CRC card methodology is informal, but we should go through the following steps when using it to analyze a system. The first step is to develop an initial list of classes where we will write down the class name and new words on what it does. A class may represent a real-world object or an architectural object. Identifying which category the class falls into is helpful. Each person can be responsible for handling a part of the system, but team members should talk during this process to be sure that no classes are missed and that duplicate classes are not created. The second one is to write an initial list of responsibilities and collaborators where the responsibilities list helps to describe in a little more detail what the class does. The collaborators list should be built from obvious relationship between classes. Both the responsibilities and collaborators will be refined in the later stages. Create some usage scenarios. The scenarios describe what the system does. Scenarios probably begin with some type of outside stimulus, which is more important reason for identifying the relevant real-world objects. The next one is to walk through the scenario. This is the heart of the methodology, in which each person on the team represents one or more classes. The scenario should be simulated by acting, that is, people can call out what their class is doing, ask other classes to perform operations, and so on. Moving around, for example, to show the transfer of data may help you visualize the system's operation. During the walkthrough, all the information created so far is targeted for updating and refinement, including the classes, their responsibilities and collaborators, and the usage scenarios. Classes may be created, destroyed, or modified during this process. You will also probably find many holes in the scenario itself. The next one is to refine the classes, responsibility, and collaborators. Some of this will be done during the course of the walkthrough, but making a second pass after the scenarios is a good idea. The longer perspective will help you make more global changes to the CRC cards. The next one is to add class relationships. Once the CRC cards have been refined, subclass and superclass relationships should become clearer and can be added to the cards. Once you have the CRC cards, you need to somehow use them to help drive the implementation. In some cases, it may work best to use the CRC cards as direct source material for the implementers. This is particularly true if you get the designers involved in the CRC card process. Let us perform the CRC card analysis for the car elevator system. Car elevator is a device which mechanically lifts a car up, for which we have the real-world classes as elevator car, passenger, floor control and car sensor. The architecture classes as car state, floor control reader, car control sender and scheduler. For each class, we need the following initial set of responsibilities and collaborators. The CRC card for the car elevator is shown. You can see it consists of the classes, responsibilities of each classes and its collaborators. So that's all about the architecture design using CRC card methodology. Thank you.